It is very important to observe in vertical sections the first occurrence of a taxon and the last occurrence of a taxon. Suppose in a vertical succession, this is the observation that there is a first occurrence and then there is a last occurrence, and somewhere else in the world in section A the same species is found to occur within this range. Somewhere else we are finding this is the range, and somewhere else we are finding this is the range. So, in the different stratigraphic successions A, B, C and D in different places of the world, they have been observed. And imagine this is the time scale, this is t equal to t1 time and here t equal to t2 time. FO and LO information from so many places, here it is FO, here it is LO, FO and LO, and here it is FO and this is LO. We observe that there is a range where the species is not coming, and that is within this range T9 to T11, within this time range it was not there. What can be the reason? Same species or same taxon we are dealing. This might be the place where the taxon was not preserved, or due to environmental change it shifted for a while. So, by compiling the LO and FO, by making a global compilation, what do we get? The first appearance datum and the last appearance datum. The FAD is FO in some section and LAD is LO in some other section. So, in this way the first appearance datum of a species, or more generally speaking a taxon, can be defined. The LAD or the last appearance datum of a species, or generally speaking a taxon, can be defined. FAD and LAD are very important. We will see in biostratigraphic correlation that these terms come into the picture. So, here what we discussed mainly is that FO and LO and FAD and LAD, these are the local information, and after compiling we get the global information. This means somewhere in the vertical succession you observed FO and LO, always consult in the literature the FAD and LAD of that species, if that species is at all reported. If the species was not reported, then it becomes a responsibility of the paleontologist to search worldwide and find out the FAD and the LAD. We may find by looking at well established global compilation of the succession that a fossil with such morphology has evolved with time. As I am drawing a circle and then drawing a line, that means some complicacy in morphology, then increase in complicacy and then further increase in complicacy. This diagram is not of any specific fossil. In fact, fossils will not have this kind of morphology. This is just a schematic presentation. Now, in some locality you find this kind of succession. The same species that we were dealing here, some of them are found, and X is a new species. So, we can ignore that. The problem is that if we consider a part of it, then this is young and this is old, and now I am getting what? Here is old and here is a young. So, the question is, how is this possible? There are two possibilities. Number one, what we are observing in B underwent 180-degree overturn. So, it was initially like this, then it took a turn and became like that. So, that this is the final product. Or the second possibility is that these two different species were coeval, that means they were together, but they were selectively preserved. It means that, imagine we are dealing with a section where this is found and in the next layer also this is found, and after that by some mechanism maybe this got dissolved and got out and this got dissolved and got out. So, what is left is only this and that, but then the moment we think like this, this is going against the well established concept globally. So, you are challenging the global concept. In this case, it becomes your responsibility to find out from other sections in the world whether it is true. So, we need more proof. We can obtain fossils from the vertical successions going to the field by carefully breaking the samples. The other possibility is that we drill vertically and pick up the drill core, which is cylindrical in geometry. So, when this cylindrical drill core is picked up, this side is top and this side is bottom, but here defining the first occurrence of the fossil or taxon, a few things to be remembered. When we are doing the drilling exercise, drill cuttings come. These are the small chips produced during the friction in between the drilling machine and the rock. So, that is being shown by these angular fragments. So, what happens, suppose from the drill core, this is the actual first appearance, some pieces may break down and fall here and they will get mixed up. So, now the word of caution becomes rely only on the outcrops and on the cores. On this core you fully rely for FO and LO, but not on the drill cuttings. We do not take drill cutting to define the FO and LO. Only from the drill cutting what can be done? We can identify different species present. We can of course identify species, but finding out the time of first occurrence will not be possible in this case. Now, once we have defined FO and LO, FAD and LAD, and we have discussed about how to pick up the data from the drill core, a few more terms are to be understood. First, consistent occurrence, peak occurrence, last consistent occurrence and the last occurrence. In this way, we can describe a taxon in a vertical succession. Now, let us look at the graphical presentation of the abundance of the species, and in paleontology and stratigraphy such diagrams are very commonly used. Say this is a vertical succession and here less number of fossils were found. This is the peak zone where so many have been obtained, then it vanishes for a while, then again a few cluster here, and this is followed by reduced in number and then the last occurrence. How do we present this information in a graph? To do this, I can draw a vertical line and I count the number of specimens within this horizon and I create a curve like this. This curve indicates what? This is the peak occurrence, and then we can see over here the occurrence is vanished. So, I join it here. Now, here it goes like that, and again the number of fossils have increased and it comes over here. After that again there is no fossil, from here to here it increases and again comes over here. Then there are few number fossils, so it goes like that and it ends over here. What has been drawn at one side, at the other side is also drawn symmetrically. This is a graphical way of showing the abundance of fossil. Since I find this blue curve touching the black line, this is a zone where no fossil found. This is a peak. There are smaller peaks here and here also is a smaller peak. This can be a much better diagram, because in my previous diagram I drew curves like this. It is not very much true in all the cases that so abruptly from the peak towards upward direction the fossil abundance decreases. It can decrease actually smoothly. So, this is one side and the other side has to be drawn in a symmetric manner. Now, we are going to see the signal-Lipps effect. What does it say? It says that the artificial gradual origination and extinction pattern of the fossils of the species have been observed in the rock succession. Extinction can be a sudden process. It cannot be gradual, but due to the reduced sample size or due to the rarity of the species, not all species can be preserved. Even if they are preserved for few million years, later on due to other activities, due to solution or cracking, breakage, it may get destroyed, or a phase change can preferentially preserve the fossils. Unconformity can be there when no fossils can be found, and the different sedimentation rates control the fossil preservation potential. So, as a combination of all these effects, there can be gradual origination and extinction pattern that can be seen in the rock record, and this is known as the Signor-Lipps effect. We have to also keep this in mind while using the biostratigraphic concepts. Once we observe some taxon or we do not observe any taxon in a rock record, we have to raise some critical questions. Is it true presence? Are we dealing with the reworked fossils? If so, avoid the reworked fossils. Geological reworking. Is there any error in identification? Have we correctly identified the species? Had there been any sample contamination? When we say taxon is not observed, is it truly absent? We should always raise a question. For example, is it due to the ecological exclusion, due to ecological reason the fossil was not preserved? Is it not recorded due to poor preservation? It was there, but then it was not preserved. Another possibility. Is there an error in identification, so that we are wrongly identified some species and saying that certain taxon or species are not present? Is it due to the low population density, that they were there, but they were very fewer in number, so they were somehow not preserved? Or is it an issue of sedimentation rate, that due to certain sedimentation rate the fossil was not preserved? Let us look at how biostratigraphic classification can be made. This time we will take an example of plant fossils, typically the leaf. Let us look at first of all the area of consideration. This is the western side of Bangladesh, and east to that is the Indian states such as West Bengal, Jharkhand, Orissa, and then there are other states Chhattisgarh, Maharashtra, Andhra Pradesh, Madhya Pradesh, Bihar. North of Bihar is the country Nepal, and west of Bihar is Uttar Pradesh. Some of the big locations: Kolkata, Bhubaneswar, Patna, Bhopal, Hyderabad. Here the different numbers represent the Gondwana basins. 45 is here, 18 is here. These are all the Gondwana basins. A specific supergroup of rock is exposed in all these areas. These Gondwana rocks have been classified earlier into two divisions: the lower Gondwana rock based on the Glossopteris fossil plant leaf, and the upper Gondwana based on the presence of the Tylophyllum. How do they look like? The Glossopteris plant fossil looks like this. This portion might not be preserved in all the cases. They came into existence in Permian. Interestingly, they are now extinct. They are the seed plants. They are the tongue shaped leaf. This geometry has been called as tongue shape. Glossopteris was used to identify the lower Gondwana sediments. The upper Gondwana was identified based on the Tylophyllum fossil. This is the Tylophyllum. This is an extinct genus. That means at present on the earth we do not see any plant exactly with such leaf. The geometry of the leaf is markedly different. They are sharp and thinner compared to the Glossopteris. However, later a threefold classification of Gondwana stratigraphy was made. Gondwana rocks were divided into the lower Gondwana, middle Gondwana, and the upper Gondwana. Lower Gondwana was as usual defined by Glossopteris, and what was earlier done to identify the upper Gondwana using Tylophyllum was maintained the same. A new addition is the middle Gondwana based on the Dicroidium fossil. This is how the Dicroidium looks like. These are the seed ferns, and the leaf can be identified. Not just in the Indian continent, but in other continents also these fossils have been identified and the Gondwana sediments have been classified. A more detailed classification than this exists at present. Students have to remember this scheme and that scheme very well. They also have to remember that the Glossopteris and the Tylophyllum are extinct at present. Use of biostratigraphy has been made very extensively from the Kutch basin, where it is located. This is the Indian peninsula, this is the Gujarat region, this is the place where the detail has been shown in this map. The lithologies exposed in the Kutch mainland is presented here, and typically this Mesozoic portion is very important. The Jhurio formation, the Jumara formation, the Jhuran formation and the Bhuj formation, over which comes the Deccan Trap formation, and the age of this typical Kutch stratigraphy is Mesozoic. Just want to refer here that ammonites and gastropods have been used to define the biozones within the Jurassic period of the Kutch basin. In the biostratigraphy class, we need to remember that from the Kutch basin, biostratigraphic approach was taken using gastropod and ammonites. Biozones were defined for the Jurassic period rocks of the Kutch basin. The stratigraphy of Kutch basin consists of Jhurio formation, Jumara formation, Jhuran formation and the Bhuj formation, and this is the entire Mesozoic range. The tectonic detail has been presented in this work, basically picked up from this research paper. In quantitative biostratigraphy, several parameters can be deduced and they are helpful, and we can call it relative biostratigraphy value of the taxa. Note here we are using the word taxa. So, as I said, this word can indicate taxon, can indicate species, genus, family, order, etc. What is the vertical range V? It is the thickness of sediment in section occupied by species I and divided by the total thickness of section M. Say this is a vertical section, and within this range we are getting some species I, and this thickness is M and the total thickness is M. Then V is equal to M by M. Is it possible to have V equal to 1? Yes, of course. If we are dealing with a vertical succession and from top to bottom we are having species I, then M equal to M, which means V equal to 1 is possible. What about V equal to 0? This is a case when there are no fossils, it is a barren stratigraphic succession. M is equal to 0, capital M still remains, and then V becomes 0. Is it possible to have V more than 1? The answer is no, because a part of the succession cannot be bigger than the whole of the succession. So, V more than 1 is not possible. Now, we will define facies independence F as a relative biostratigraphic value of taxa. It is the number of facies in which species I occurs, or I can say taxon here. We know that the facies itself is qualitative. Facies is defined in a qualitative manner, and from person to person there is a chance of variation. If that is the case, then this parameter can also vary from person to person for the same outcrop and same vertical succession. So, we mean that the facies independence F may be subjective. What is it? Number of facies in which species I occurs divided by the total number of facies which is studied, and it can be more than 0 or equal to 0, it can be equal to 1 or less than 1. F equal to 0 means what? That means a barren stratigraphic succession, no fossils are found. So, F equal to 0 and V equal to 0 mean basically the same thing. Here we are dealing with thickness, but here we are dealing with the number of facies in the numerator and denominator. I forgot to refer that V is unitless, because you see thickness divided by thickness unitless, and here facies independence F, this is also unitless. F is equal to 1 means what? I am considering 3 facies in a vertical succession and 3 of them have got species I or the taxon I, then it is F is equal to 1. So, this F equal to 1 can be somehow comparable with V equal to 1. F less than 1 means what? Say I am studying 7 facies and out of that 5 have got fossils, or the typical species or the typical taxon we are looking at. In that case, F is less than 1. F more than 0 means what? There is at least some facies where the species or the taxon is found. We will now see the parameter G, which is called the geographic persistence. Here the number of sections where species I is occurring divided by the total number of sections. So, as per the definition, this is also unitless. G equal to 1 means what? that let us say there are 3 sections P1, P2 and P3 where the species I occurs, and 3 of them we are considering. So, that is the meaning of G equal to 1. In all the sections species is occurring. G less than 1 means what? Say we are dealing with 4 sections, I is occurring only within P1, P2, P3 and not in P4. In that case G will be less than 1. G equal to 0 means what? We are dealing with barren successions. There are several successions where in none of them there are fossils. Is it possible to have G more than 1? The answer is no. So, V, F and G maintain this relation. They lie between 0 to 1 and they can be equal to 1 or they can also be equal to 0. And the classic index fossils have high G, high F and small v. I said that the index fossils, when these organisms were living, they were occupying a large extent, vast stretch. So, that means the number of sections where I will get is a large number, let us say 0.8. So, even though remaining less than 1, it is relatively large. For the index fossils, what about F? The definition of F we did here is a number of facies in which it is found. So, it is found in so many places. So, F will also be a large number, and still once we say large number, whatever be it, it is still less than or equal to 1. G here also can be equal to 1. It will have a small v. Why? Look at the definition of the vertical range V. It is the thickness where it is found. I said index fossils have a shorter geological span. So, small m should be much less than capital M, and this means that V will be small number. Now, using F, V and G, one can find out the relative biostratigraphic values RBV. There are 3 parameters RBV1, RBV2 and RBV3. RBV1 is equal to F multiplied by 1 minus V plus 1 minus F multiplied by G. RBV2 is equal to F multiplied by 1 minus V plus G into 1 minus V divided by 2. So, this G remains the same and F is replaced by V in this case, and here F1 minus V and F1 minus V are the same. RBV3 is simply 1 minus V. We are seeing 1 minus V in so many places. We are finding it here, we are finding it here, here and here, and of course, we are also seeing 1 minus F. What is the meaning of 1 minus V? Let us say this is a total stratigraphic succession of height h, and within that height B is occupied by a species I. So, H is equal to A plus B plus C and V is equal to B divided by H. So, RBV3 is equal to 1 minus V, 1 minus B divided by H is equal to H minus B at the numerator, which is equal to A plus C divided by H. A plus C is what? As per the diagram, is the total thickness of succession. I am not writing because of lack of space, of succession without species I or without the taxon I. So, this is the meaning of 1 minus V. We can also be interested to know what is the meaning of 1 minus F. It is very easy. Let us look at the definition of F. F, facies independence, F is equal to number of facies in which species I occurs divided by the total number of facies. So, 1 minus F will be equal to 1 minus the definition of F, which is number of facies where I not existing divided by total number of facies considered. So, in this way, this is the meaning of 1 minus F. In RBV1 we are involving F, V and G. In RBV2 also we are involving F, V and G, but in RBV3 we are only involving V. G and F are not there. Now, it can be shown that RBV also lies between 0 to 1, it can be equal to 0 and it can also be equal to 1. RBV nearly equal to 1, maybe RBV1 nearly equal to 1 or RBV2 nearly equal to 1 or RBV3 nearly equal to 1 indicates taxon is good for biostratigraphic correlation. So, we can take several taxa and find out the RBV values and then decide which one will be a better biostratigraphic correlator. RBV nearly equal to 0 means poor correlator in biostratigraphy, and the taxa with RBV nearly equal to 0 should be avoided as the index fossil. Why RBV implies poor biostratigraphic correlator? The fossil is poor biostratigraphic correlator, and I will take example of RBV3, and we have defined it is equal to 1 minus V, and as per this diagram it is equal to A plus C divided by H. Now, if this is equal to 0, this means A plus C equal to 0, this means this B is equal to H, which means the species I occupies the entire of the succession and it is not occupying a smaller part of the succession. This indicates species I occupies entire succession, and therefore, it cannot be a good index fossil. To be an index fossil, to be a good biostratigraphic correlator, the fossil should appear and disappear within a short time span.